Hello, welcome to the channel. The problem of today is from algebra AP. Let A1, A2, A3, A4 A and be n positive consecutive term of an AP. If d greater than 0 is its common difference, then limit n tends to infinite a square root of d upon n into 1 upon a square root of a1 plus a square root of a2 plus 1 upon a square root of a2 plus square root of a3 plus plus 1 by a square root of a n minus 1 plus a square root of a n is among these four options, which one will be correct. Let's see the solution. We have given as a1, a2, a3, a4 n positive consecutive term of an AP, d greater than 0. Here t is our positive. And since the sequence is in AP, that is A2 minus A1 equal A3 minus A2 equal A4 minus A3 equal AN minus AN minus 1 will be our D. This is given and D is positive. Now we have to evaluate limit n tends to infinity D by n square root and 1 upon a1 square root plus a square root of a2 plus 1 upon a square root of a2 plus a square root of a3 plus 1 by a square root of an minus 1 plus a square root of a. We have to find its limiting value. Now rationalizing, and we get limit n tend to infinite d upon n square root, and after rationalizing we get a square root of a1 minus a2 in numerator by a1 minus a2 plus similarly a square root of a2 minus a square root of a3 upon a2 minus a3 and so on. an minus 1 पहले था an minus 1 square root minus a square root of an by this becomes a n minus 1 minus an. Denominator can be written as minus d because a2 minus a1 is our d, and this can be written as minus d, and a2 become cancel out after cancelling because denominator is of equal term, and this becomes a square root of a1 minus a square root of a2 plus a square root of a2 minus a square root of a3 and plus a square root of a n minus 1 minus a square root of an upon minus, and this term minus 1 will become cancelled before this, and we have a square root of a1 minus a square root of an, and taking minus sign as common we get a square root of an minus a square root of a1 by d, and writing an as nth term can be written as a1 plus n minus 1 into d square root minus square root of a1 by d. Now, a square root of d to a square root of d. This becomes a square root of d. This can be written as limit n tends to infinity 1 by a square root of d. And this square root of n is taken inside the square root. We get a1 by n plus n minus 1 upon n into a square root of d minus a1 by n square. Therefore, this gives limit n tend to infinity 1 by a square root of d, and this becomes 0 plus 1 minus 1 by n square root of d, and this becomes 0. This becomes also 0. 1 into d a square root of d, that is 1 by a square root of d into a square root of d is the value as 1. That is, the limiting value of the given problem is 1. Option C is the correct option, and hope you will understood it well. Best of